Hello everyone. Today we are going to start from the optical fibers. What is optical fibers? Optical fibers consist of the several thousands of very long fine quality fiber of glass. The diameter of each fiber is of the order of 10 to 4 centimeter, which refractive index of material being in the order of 1.5. Optical fibers are used in the transmission and reception of electrical signals by converting them first into light signals. That is known as optical fiber. It's a very tiny, we can say that, very tiny fibers which has a reception of the electrical signal by converting them first into light signals. So there is a refraction at a convex or concave spherical surface is mu by b and minus 1 by u is equals to minus mu minus 1 by r. The refractive index is given here. U is distance object, b is the distance of images, and r is radius of curvature. Now we come on the lens. Lens is the uniform transparent medium bonded between the two spherical and one plane surface. So these are two types, convex and concave. The lens thinner which is thinner at edge and thicker at middle is called convex, and a lens which thicker at edge and thinner at middle is called concave. So lens formula is very popular, that is 1 by f is equals to 1 by v minus 1 by u, and the lens maker's formula is 1 by f is equals to mu minus 1 into 1 by r1 minus 1 by r2. Now what is the power of lens? The reciprocal of the focal length of a lens, which it is when it is measured in meter, is called power of lens. What is the power of lens? P is equals to 1 by f meter and its unit is diopter d. The power of convex lens is positive and concave lens it is negative. What is the combination of focal length and lens? When lenses are in contact, that is 1 by f minus 1 by small f1 plus 1 by small f2, and the power of the combination P is equals to P1 plus P2. When lenses are separated by a distance small d, that becomes to 1 by f is equals to 1 by f1 plus 1 by f2 minus d into d by f1. So that is the power of combination. So P is equals to P1 plus P2 minus D into P1 P2. So the linear magnification is M is equals to 1 by U, O is equals to V by U. For same as where linear magnification is used before, that's why M is equals to I by O is equals to V by U. For a small size object placed linearly along the principal axis, it is axial, that is known as longitudinal magnification, which is given below, that is minus dv by du is equals to b by u whole square, and that becomes to f by f plus u ka whole square is equals to f minus b by f ka whole square. Now the focal length of the convex lens by displacement method. How can we find the focal length of a convex lens? In which method? That is displacement method. And the focal length of the convex lens, f is equals to a square minus d square by 4a. A is equals to what? The distance between the images, a pin and object pin, and d is equals to distance between the two position of lenses. So the height of object is equals to O is equal to under root I1 I2. So how can we become on the point is cutting of a lens? What is this? If a symmetrically convex lens of a focal length, it is cut into two parts. First is optic axis, so then the focal length of the each part is become to 2f. So one part is also 2f and second part is also 2f. So if a symmetrically convex lens of a focal length is cut into two parts along the principal axis, then the focal length of the each part remains unchanged, as similar as in the figure is given. So different f by 2 f, and it is infinity. So the combination of the focal length of combination is f by 2, but the joining two parts in opposite chances net focal length becomes. Now this section is discussion due to we have become on the point that is known as the prism. It's a look like a prism. And how can we understand the prism? Prism is a uniform transparent medium bounded between the two refracting surface inclined at an angle. That is the two parts. That is the two parts, and decline same parts, one light, second and third. So these terms we have discussed on. The prism is a uniform transparent medium bonded between two refracting surface, one refracting surface and two refracting surface inclined at an angle. So that are inclining section also. Now how can we understand the point is here? Angle of the deviation and angle of the dispersion and deviation. 2 points is here raised due to the prism. The angle subtended between the direction of incident light ray and emergent light ray from a prism is called angle of deviation, that is denoted by del, and the become a dispersion of light, deviation and then dispersion, the splitting of white light into its constituent colors, and in 7 colors, that is known as VIBGO, that is known as dispersion. In this section, what is the one term is coined here is the prism formula. What is the prism formula? The refractive index of material of prism mu is equals to sine into A plus del m by 2 by sine A by 2. It is a prism formula which is very useful. Now angular dispersion, whenever dispersion is happen, that becomes to angular dispersion. The angle subtended between the direction of emergent violet and the red rays of light from a prism is called angular dispersion. So how can we find the angular dispersion? So theta and del v is minus del r is equals to mu v minus mu r into a, where del v they are angle of deviation. Now the dispersion power is recognized with the help of this formula. W is equals to theta by del y is equals to mu v minus mu r by mu y minus 1, where mu y is equals to mu v plus mu r by 2. It's mean refractive index. Now become on the next point, it is human eyes. So it is also a spherical lens. Human eye is an optical instrument which forms real image of the object on retina. So retina color content, lax of the cone and the rod cells, which of light and intensities of light respectively. So here is a diagram of the eye which are the different sections. It is a retina, yellow spot, optic axis, and this is the lens. Although it is vitreous humor and crystalline lens. Here is the aqueous humor, and visual axis, it is iris, is the ciliary muscles, and there is the optical nerves, which is capacity to give us how can see the object. Then ciliary muscles change the focal length of the eye's lens, and this power of eyes is called power of accommodation of eyes. So the terms is power of accommodation of eyes. Different defects on vision exist in the human being, that is myopia or short-sightedness. It is a defect of eye due to which a person can see nearby object clearly but cannot see far away object clearly. Is this if a defect, the far point of eye shift from the infinity to a nearer distance, this defect can be removed by using a concave lens of appropriate power. Now this is the diagram. This is a diagram of normal eyes which is given here, and whenever the defects of vision is present, this is the defects of vision diagram of eyes. It is very important diagram whenever the question is asking what is the diagram of myopia eyes and what is the correction. So whenever we are going to correct, the section is important. This is the correction, it is the myopic eye, and whenever using the lens, that is a corrected eye. And so we can, whenever wants to describe that, both diagram is necessary to describing. First is the myopic eye, that is the defect eyes, and that is the corrected eyes. So now hypermetropia or long-sightedness, in this defect a person can see far away object clearly but cannot see nearby object. So in this defect a near point of eye shift away from the eye, and thus defects can be removed by using a convex lens of appropriate power. So this is the diagram. It is normal eyes, and it is a hypermetropic eye, that is meant by defects of vision, and after correction it becomes to like that. Now we understand the third point. It is very normal astigmatism. In this defect, a person cannot focus on horizontal and vertical lines at the same distance at the same time. So this defect can be removed using the suitable cylindrical lenses. Now the color blindness, it is very rarely in this defect distinguish between few colors. A person is unable to see. The reason of this defect is the absence few colors of cones cells sensitive for this defect cannot be removed. Cataracts in this defect, an opaque white membrane is developed on the cornea, due to which person lost power of vision partially on completely. So this defect can be removed by removing this membrane through surgery. Now all these things is depend upon the lenses. Then one optical instrument also here when we have discussed, that is known as a camera. What is a camera? A camera is consists of a light proof box at one end of which a converging lens system is fitted and the light sensitive film is fixed at the other end. So opposite to the lens system, a real inverted image of the object is formed on the film by the lens system. What is the f number of for a camera? That is the f number. What is the f number? That is means by focal length of camera, diameter of the lenses. Generally that is the different numbers, 2, 2.8, 4.8 are the f numbers, and the amount of light entering the camera is directly proportional to the area of aperture. So L is directly proportional to aperture, and aperture is directly proportional to d, that is meant by diameter of lens, d square. So brightness of image is directly proportional to d by 2 by f2, where d is equals to diameter of the lens, and that is described as previously exposed time. In the time is the time for which light is incident of photographic film. Now we become on the next optical instrument, that is simple microscope. It is used for observing magnified image of object. It is consists of the converging lens of a small focal length. So that is the magnifying power of microscope, and when a final image is formed at the less distance of distinct vision d, then m is equals to 1 plus d by f, where f is the focal length of lens, and when the final image is formed in infinity, then m is equals to d by f. So it is basically, this diagram is useful to us for the simple microscope, and this diagram is used also in the mirror formula and a lens formula also. We can solve the questions of this type with simple microscope using the lens formula. Now microscope, and next compound microscope. It is a combination of two convex lenses called objective lens and eyepiece separated by a distance. Both lenses are of a small focal length, but f0 is greater than fe, where f0 and fe are the focal lengths of the objective lens and eyepiece respectively. So these are things as diagram is given here. So magnifying power m is equals to magnifying power of compound microscope, m is equals to v0 by u0 into 1 plus d by f0, where is the v0 is what? The distance of image formed by objective lens, and u0 distance of object from the objective. When final image is formed at infinity, then m is equals to v0 by u0 into d by fe. Now astronomical telescope is very useful for astrologers. They are finding the stars, planets. It is useful to astrologers basically, and astronomical optical instrument. It is also a combination of two lenses called objective lens and eyepiece separated by a distance. It is used for the observing distinct image of heavenly bodies like stars, planets, all these things. It is very useful to watching these things. We have discussed in the next classes. Magnifying power, when final image is formed at least distant of the distinct vision d, then m is equals to f0 by fe into 1 plus d by fe, where f0 and fe are the focal lengths of objective and eyepiece respectively. Length of the telescope L is equals to f0 plus uz, where ue what? It is the distance of object from the eyepiece, and when the final image is formed at infinity, then what will be happen? The m is equals to f0 by fe, and the length of the telescope is what? The f0 plus fe. So it is a mathematical formation of the finding the length of the telescope, and for the large magnifying power telescope should be larger. and the large magnifying power of microscope should be small. So resolving power, the ability of an optical instrument to produce a separate and clear image of two nearby objects is called resolving power. And what is the resolution? The limit of resolution of these things in this instrument. So this minimum distance between the two nearby objects which can be just resolved by the instrument is called its limit of resolution. So resolving power of microscope is equals to 1 by d is equals to 2 mu sin theta by lambda, or d is equals to limit of resolution and lambda is equal to wavelength of light used. Mu is equals to refractive index of the medium between the objects and objective lenses, and theta is equals to half of the cone angle. Resolving power of the telescope is equals to 1 by d theta is equals to d by 1.22 lambda, where d theta is equals to limit of resolution, a is equals to wavelength of light used, and d is equals to diameter of aperture of objective. Now the point is, every aberration of lenses, the images formed by the lenses suffer from the following two Reynolds drawbacks. Spherical aberration of a lens, due to which the rays passes through the lens are not focused at a single, and the image of a point object placed on the axis is blurred and called a spherical aberration. It can be reduced by using lens of large focal length and plano-convex lens, cross lenses, combining convex and concave lenses. So the second point is chromatic aberration. What is this? The image of white object formed by the lens is usually colored and blurred. This defect of the image produced by the lens is called chromatic aberration. Now we come on the point of scattering of light. That is very important. When the light passes through a medium in which particles are suspended whose size is of the order of the wavelength of light, then light on striking these particles deviated in different directions. This phenomenon is called a scattering of light. According to Lord Rayleigh, the intensity of a scattering light I is directly proportional to 1 by lambda 4. Therefore, red color of light is scattered least and violet color of light is scattered most. Daily life example of a scattering of light is blue colored of sky, which is 2 red color of the signals of the danger, black color of the sky in the absence of atmosphere, red color of the time sunrise and sunset, and the human eye is the most sensitive to the yellow color. थैंक यू फॉर वॉचिंग एंड मैं इसमें प्रीवियस क्लास का लिंक सेंड कर रही हूँ. यदि आपको कोई परेशानी हो, क्योंकि बच्चे बुक्स नहीं पढ़ना चाहते हैं, तो हमने शॉर्ट नोट्स बनाया ताकि आराम से आप लोग इसको सुन सकें एंड समझ सकें. थैंक यू.